In this episode of the Junior PenTester training series, we're going to go through active reconnaissance. And active reconnaissance is the counterpart to passive reconnaissance. And this is going to now show up on the security devices, right? On the endpoint detection, on the intrusion detection systems, and everything else. This is actually going to show up mainly because of the fact that we are now going to be scanning. We're going to be using tools like Traceroute or Ping or Telnet or any other information or any other type of tool that will actually get you much more detailed, nuanced information about your target. And maybe things like your web browser scanning or your web browser looking at the source code of a web application. Maybe that might not show up on the actual security defense tools, but for the most part, the way that I differentiate between passive and active is that active recon shows up on the security devices, on the endpoint detection and all of that stuff. So that is what we're going to be talking about in today's video. And of course, we're going to talk about the intro, the web browser itself. We're going to use the Ping tool, Traceroute, Telnet, Netcat, and then we're going to put it all together and actually run a couple of exercises together to be able to get the final kind of full circle wrap up of this particular video, of this particular episode. This is another free room that's available through TryHackMe, meaning that you can actually launch the virtual machines, the attack box, and all that good stuff inside of this by just having a username and a password. So it's one of the hundreds of free rooms inside of TryHackMe. It was developed by Strategos and TryHackMe, of course. The timestamps for every single one of these are going to be in the description below. So if you just want to jump around and find specific information for your task where you're at, you can go ahead and do that. But apart from that, that's what we got for today's episode. So quick note from Hackaholics Anonymous, and then we'll jump into it. If you're serious about your SysAdmin education and you want access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the supporter, agent, guardian, and master. Each tier gets their own Discord server and early access to content. The agent, guardian, and master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you'll be able to join Hackaholics Anonymous. Now, without further ado, let us jump into active reconnaissance. Now, I mentioned in the last episode where we were talking about passive recon, I mentioned that we do go much deeper into reconnaissance in general in the CompTIA Pentest Plus training series, and all of those videos are already up, so you can actually go find them in the CompTIA Pentest Plus playlist. Now, in this particular video, we're going to be going through some of the most, or surface level, I should say, some of the more surface level introductions to these tools. And of course, we're going to be looking at a web browser to see what we can find about a website or the target. We're going to use Ping, we're going to use Traceroute, Telnet, and Netcat to gather more information about the network system, their services, all that good stuff. So passive recon, again, allows you to gather information about the target without any kind of direct engagement or connection. You're watching from afar, like using binoculars to look at your target. Active recon allows you to make some kind of contact. So it could be a phone call, right? Or you visit their company under some kind of pretense to gather more information, like a customer. I just want to introduce myself, or I want to see, I want to get more information about your services. Oh, by the way, do you have a business card? And then you get their business card, and then you get their email address on the business card. And there's a lot of other things, right? So it's a direct connection to the target, and it could be a direct connection to their system, looking at their website or checking if their firewall has an SSH port open. This is much more active than anything else that we've talked about so far. And it's much more active than just looking at their website, right? So I honestly, I would consider looking at their website as passive reconnaissance. As long as you don't do any kind of scan on their website and you're just looking at the website, clicking around, looking at the source code, all of that, in my opinion, is considered passive recon. But it's been listed here as active recon because technically you're engaging with the target. So think of it as closely inspecting windows and door locks, right? Going up to somebody's car and pulling the car handle to see if the car opens and it's unlocked. That's kind of what we're doing in this sense. Except we're just doing it in the digital realm, right? So it's essential to remember not to engage in these things before getting signed legal authorization from the client, because the instant that an organization finds out that you're doing active scanning, of course they're going to block you, but depending on what you're doing in your active recon, they may actually report you and you may get into severe legal trouble. So just remember, when you're doing pen testing, you are hired to do a penetration test, or you're going through a website like HackerOne or something like this, where they have publicly contracted the all of the hackers of the world and saying, okay, you are allowed to attack us, and we'll even pay you if you find some kind of a bug bounty, or if you find a bug in our services, we'll actually pay you to point that out to us, and then they'll give you the rules upon which you can act and what you should and should not do, and then from there you're free to go work along it. But that's like the furthest that you can go without getting direct permission from somebody via a signed legal authorization. So just keep this piece in mind, right? It's illegal to do this without permission. So what we're going to be doing is doing the active recon element of it, and it looks at direct connections made to the target machine, and the information will leave that connection that you would do. It'll actually leave information in their logs showing the IP address that you're using, the time of the connection, duration of the connection, and many other things. And we're not going to be talking about using things like proxies or proxy chain and things like that, but there are ways that you can technically hide your specific computer's IP address. And you can go through the Tor Onion browser, which has technically a proxy chain embedded into it. And then you can even expand on that proxy chain. But even that can be reverse engineered. And ultimately, they can find out, if they have a really good security team, a defensive team, they can find out who you are and where you were and what you did. And it's just, again, make sure that you do all of this with permission so you don't have to worry about getting into trouble. So not all of the connections can be suspicious, because your active recon can appear as a regular client activity. So you can actually disguise yourself and shield yourself against seeming malicious. Web browsing is one of those things where it's like you're a browser, you're connected to their website, you're going to their target web server. Unless you're trying to go to their admin login portal and you're not an admin and your IP is not listed on the list of admin IPs that they have, that can be suspicious. But if you're just going through their website, clicking around, trying to find information, it's not really suspicious. It's just like somebody's going and browsing their website. So you can use these types of techniques to your advantage when you're doing red teaming, where you're on the attacking team and you don't want to alarm the blue team, which are the people on the defensive side. So we're going to be using these types of tools that come mostly they come with most of the operating systems, or they're easily attainable. If you have Kali Linux, all of these things are already embedded, pre-installed into Kali Linux. So the web browser obviously is already pre-installed, right? So web browsers are really easy to access, and we'll show you how a web browser can actually be armed to become an efficient recon tool. Then we're going to go through the rest of the tools, for example, ping, traceroute, telnet, etc. So all these things establish a connection to the target. Therefore, your activities would fall under active recon. And if you want to get into the pen testing realm and you want to get familiar with these tools and how you can use them in active recon, this is the video for you. And if you want to go deeper into it, then you can go ahead and use the CompTIA Pentest Plus playlist and go through those videos for the section of Reconnaissance, and you'll get even more tools and even more strategies and tactics that you can use to do active recon. Now, if you're not a subscribed member of TryHackMe, meaning if you're not a paid subscriber, the attack box is not going to have internet access, so you'll need to use the VPN to complete the questions that require internet access, meaning you can actually be a free member of TryHackMe and use OpenVPN to establish a connection to your own computer and then use the internet that's available on your computer to run the exercises. So that is what we're going to be doing. And now let's talk about the web browser. You can use the web browser in a variety of different ways to get information about your target on the transport level, which has to do with the OSI model. So if you aren't familiar with that, then I would refer you to learning a little bit more about networking. So on the transport level, the browser connects to the port 80 by default, and this is through HTTP. Now, HTTP is plain text, right? So when you're connecting via port 80, you're essentially looking at the entire communication between you and the website without encryption. Port 443 is the secure version of HTTP, which would be HTTPS, the HTTP secured, and that is an encrypted connection. So that information would need to be decrypted somehow if you want to really get good information about the website. And most modern websites, if the web developer knew anything about anything really, they would be operating via port 443, which is protected with SSL or TLS certificates, okay, or those levels of encryption. So since 80 and 443 are default ports for these communications, the browser doesn't show them in the address bar. However, it's possible to use custom ports. For instance, 127001, this is the loopback local address on every single computer, right? So if you do 127001:8834, it'll connect to your local host on port 8834 via HTTPS. And in this piece right here, this is where you're declaring that you're going to use HTTPS. If you were to do HTTP without the S, then it would do it without the encryption, right? If there's an HTTPS server that's listening on that port, we'll then receive a web page. But most likely there isn't, because typically this is like and if there was, this would also be something that would be only accessible from that local machine, because it's the local host's IP address. So if you have something on your local host at this port, me trying to connect to this specific IP address, even though I use the right port, it's not going to bring up anything for me because it's on your local host. Hopefully that makes sense. Like, this is the IP address for my local host and your local host. But if I don't have that website on my local host, it doesn't matter what I do here. It's just not going to show up for me. So while browsing the web page, we can do Control-Shift-I, which if you're on a Windows PC, or Option-Command-I on a Mac, or I guess I would say Linux as well probably, to open the developer tools on Firefox, okay? You can also just do right-click, and then you can go to Inspect, and usually when you do this, it'll actually open up the developer tools. So these are the developer tools on Chrome, right? So anytime that you do that, it'll just open this up. And then what you'll see at the top right here, well, you can't really zoom in it like that. What you see at the top right here, these are the various elements or various categories, tabs inside of the developer tools, right? And on Chrome, they're named a little bit differently than what you would see on Microsoft Edge or what you would see on Firefox, but they all have them. So all of the browsers actually have these various tabs, and they'll do the same functionality. It's just they might be named differently. So this is what the developer tools looks like. You can obviously also go to the menu over here, and then from there you can pull up developer tools. So there are a lot of different ways to do it, but I usually just right click on something and then I'll do inspect and it'll open it up. And then what I really like doing when I'm trying to find something specific, or the details like the source code for something specific. So let's say this image right here. So let's say I want to find what this image is being pointed to. So I'll right click on the image and I'll do inspect. And what happens is that it actually pulls up that image. It pulls up the section of the code that houses that image, which is obviously on TryHackMe-images- or TryHackMe-images.s3.amazon AWS, etc., etc. So now we can see, okay, they're using an AWS S3 bucket to store their images. And if we went to that address, maybe we'll find something, right? So I can technically just copy this. It might be blocked because I don't have access to their S3 bucket, but maybe it is accessible. If I go here, and so it says, yeah, it doesn't appear to have any style associated with it. The document is shown below, and the access is denied because I am not one of their developers for their cloud infrastructure, right? So, but you can find that information, right? You get to see, it's like, oh, wow, this is actually being housed on an S3 bucket in Amazon AWS, etc., etc. So you can find a lot of interesting information about specific elements. So let's say there's a button, right? So this button, I can just do the same thing, right click on the button, do inspect, and it'll open it up and it'll take me to that button. So it says button color primary and then it'll even show you what it would point to if it was being redirected to a different page. Same thing with links and everything else. So that's how you can use your browser and then you'll be able to see all of these different elements. So this is what Firefox Developer Tools looks like. And so look at this, right? So it says debugger, right? So let me actually kind of zoom in on here. So it says debugger, and then debugger shows all of the various sources for this web page. But for Chrome, it doesn't say debugger. So if I go to the developer tools, for Chrome, it's actually sources. When we click on sources, then we get to see, oh, these are all of the different elements that loads when this specific web page loads, right? And that's what it will look like if you were using Chrome versus Firefox. But again, it's the same thing. It shows you the same thing that's available for this thing. So this is the login page for TryHackMe. And when you look at the source code of that, or the inspect element of that, you'll get to see under their debugger sources, you'll get to see all of these elements right here. So let's move on. There are plenty of add-ons for Firefox and Chrome that can help with this kind of stuff. But Foxy Proxy is native to Firefox. So this cannot actually be downloaded and installed into Google Chrome. And this is a proxy plugin that allows you to connect to a tool like Burp Suite, which we did a bunch of videos on it in the previous module for Junior PenTester, which was actually the Burp Suite module. So not the video before this episode, but all of the 5 videos prior to the video prior to that one. So I think it goes from episode 17 to episode 21. All of those episodes in Junior PenTester have to do with Burp Suite. And then we talk about how to use Foxy Proxy, how to capture traffic using it, etc. And you can always download it if you have Firefox using the Foxy Proxy installation page, which is the add-ons for Mozilla, which is what it looks like, right? So download it and install it. And literally it says right here, you need Firefox to use this, and I'm using Google Chrome, so it's not accessible to me. There's the user, agent, switcher, and manager, which gives us the ability to pretend to be accessing the web page from a different operating system or different web browser. So this is actually really handy. So you can disguise yourself, basically. Pretend to be browsing a site using an iPhone when in fact you're accessing it from Firefox, right? And then you can go get that for Firefox here. Now let's see if this is actually available for Chrome. Nope, this is also available only for Firefox, so boo. Then we have Wapalizer. So this is cross-platform. It's available for pretty much every web browser. And I actually have it installed on my web browser here. So I can click on plugins, and then it's right here, and click on Wapalizer, and then it pulls up all the information about TryHackMe right now. So it says for analytics, this is what they're using: marketing automation, tag managers, development, JavaScript frameworks, their live chat CRM, issue trackers, font scripts, JavaScript libraries. Platform as a service is being, of course, Amazon. Miscellaneous stuff over here, text editors, UI frameworks, all of the with one little plugin. And it's actually really, really handy when you're doing web application reconnaissance, because if you have it installed, it'll just tell you, hey, they're using WordPress as their client content management system. And so from there, we can use WP Scan. If we know that they're using WordPress, we can use WP Scan, which is a free command line tool. That'll get you so much information about their website. You can actually use it to enumerate all of the user accounts that are attached to it, including the admin accounts that are attached to it. So a lot of stuff can be found using Wapalizer, and then from there you'll know which way to direct your activity. So we're going to browse to this website and ensure that you have opened your developer tools on attack bot, and then browse the computer using the developer tools, figure out the total number of questions. So what's the website? It's this thing right here. Oh, interesting. Okay, I remember this website. So, this is using the TCP connect, or the TCP protocols, not protocols, I want to say packets. So there's a SYN packet, a FIN packet, an acknowledgement packet. These are the things that can be sent when we're trying to connect to something using the TCP IP connection. So this is the website that we're going to use for the questions. And so it says using developer tools, figure out the total number of questions. So let's go over here, inspect, right? And we're looking at the total number of questions that could potentially be asked. So we can just click on this, right click on that, do inspect. So it opens that up for us over here. And then we have what? We have the Alice bubble that has 1, 2, 3, right? And then we have the Bob bubble that has these different bubbles here. So there's 1, 2, 3 for here, little tiny bubble. And then there's another Alice bubble, which has to do with the Alice image. There's another Bob bubble, which has the Bob image. So in total, we're trying to find out the number of questions. So I guess it's what, 2? Because it says, can you hear me, Bob? And then what? And then Bob's answers would potentially be this, but we have to populate Bob's answer. So we're going to do, can you hear me, Bob? And then he says, see you later, incorrect answer. And it says, yes, I can hear you. Okay, great. And it says, okay, great. And then here's another, oh, I see. See, more things populate as we go along. So, okay, so cheesecake is on sale. He says, what? And he repeats it. Okay, so acknowledgement, I hear you. And then I'm all done, fin acknowledgement. And then, yeah, me too. And then there you go. And I guess that would be like the full conversation. But really, I mean, I still feel like the number of questions were 2. I don't think there were very many questions. So, okay, goodbye. And then I got the answer. I don't know if this is a flag that we'll need later. So THM TCP chatter. I don't know if this will actually need this for this exercise. We probably do. But we were just trying to find the number of questions. So let's see what the hint says. It says, look at the JavaScript file. I see. Inspect the file and figure out the total number of questions. So let's look at the JavaScript file inside of sources. So we can look at the script JavaScript file. There we go. So we have that. And let's go and see how many questions there are here. So Alice has, and let me see if I can kind of expand on this a little bit to make it easier. So we have, can you hear me, Bob? That's 1. What? That's 2. And then what else do we got that ends with a question? So 3, technically, what is a question? So 3, is that what it is? So those are all of the questions that we got, right? So 3, potentially. So let's see if that it is. No, it's not. So is it 2? No, it's not that either. Oh, wow. So it's more than 3, huh? All right, let me see if I can find them. Oh, you know what? It's actually, so if we go over here and look at this, the let questions portion element. So if we look at the questions variable, we can see that inside of the questions variable, we have all of these and they've been numbered for us. So there's 8 technically. And then even if we scroll down a little bit further right here, we can also see the flag right here, the THM TCP chatter. So let's try 8. I feel like 8 is the number that we're looking for. Yep, it is. So that was it. It was actually outlined for us inside of the questions variable at the very, very top right here. We can see that we have this questions variable, and inside of that questions variable, there are 8 questions in total for us. So we were able to find it. Excellent. Let's move on to ping. And for this one, I got to start the virtual machine, and I got to probably start my attack box as well. All right, while the virtual machines and the attack box loads, let's go through the contents here. So ping is a really simple tool. It's like one of the basic tools that we can use. And it basically is like ping, and then you give it the domain name. So it's like ping tryhackme.com or ping the IP address, and then it'll try to ping that. And what we're trying to see is more than one, the key thing that we're trying to see is whether or not we can establish a connection to whatever the endpoint is. And if it's up, right? So if it's up, we'll actually get a response. If we don't get a response after very many attempts, then it'll well, I can't talk. It'll either say that the thing, it'll either imply, I'm having such a hard time talking for some reason. It'll either imply that it's behind a firewall or ping has been disabled so we can't establish that connection, or it's actually down. So it's like those are one of the 2 expectations that we can have if we don't get a response from ping. But more often than not, you will get some kind of ping response or a reply, which then implies that that specific endpoint is up, right? So think about it as a game of ping pong or table tennis, right? So you throw the ball and you expect to get something back, and that's basically what it is. The primary purpose is to check whether or not we can reach the remote system and that it can actually reach us back. So this was used to check network connectivity and is still used to check network connectivity, but there are more interested different usages that we can actually find from it. So checking whether the system is actually online is one of them. So the ping command sends a packet to the system. It's an ICMP packet. It'll send the packet to the system, and the remote system will reply. And we can conclude that it's online and that the network is working between the 2 systems, yours and theirs. If you want a pickier or a more fine-tuned definition, it sends an ICMP echo packet to a remote system. If the system is online, the ping packet has correctly routed and not blocked by any kind of firewall. The remote system will send back the echo reply, right? Similarly, the ping reply should reach the first system if appropriately routed and not blocked by any kind of a firewall. Now, a lot of firewalls, just giving you some extra information, a lot of networks and a lot of firewalls, they'll block the ICMP echo ping because this can actually be something that's used for a denial of service attack or a distributed denial of service attack to bring the website down. So it doesn't really do much other than just flood the endpoint. It'll flood the remote system with millions upon millions of echo packets sent via ICMP, and so they block it from any IP addresses that aren't allowed to do the ping because they want to prevent a potential denial of service attack from taking place. So the objective of this is to ensure that the target system is online, right? And before we spend any time carrying out more detailed scans or whatever, we just want to make sure that it's up and running. So on the attack box, we can actually use ping 10.10.31.29. This is a virtual machine that was just launched, so the IP address is up. Or we can do ping and then give it the host name. And in the latter, the system needs to resolve the host name to an IP address before actually sending the packet. So if you don't specify the count, it'll just keep going until you do Control-C to actually force it to stop. So you can actually do ping and then do -C10, and it will send 10 packets, and then it'll stop automatically after it sends the 10. This is also the equivalent of doing ping N10, which is done on a Microsoft Windows system. So on Linux and Unix, it would be ping C10. On Microsoft and Microsoft Windows, it would be ping N10, and it achieves the same thing. So it falls under ICMP, the Internet Control Message Protocol, supports many types of queries, but in particular, we're interested in the echo type 8 and the reply, which is reply type 0. Getting into this is not required to use ping. So you don't need to know all of the details of ICMP to use ping, to get the results from it. So this is what they've done to do a count of 5 to this specific IP address. And then we can see that it's up and it's not blocking any kind of a request because we get to now see reply. So when it says 64 bytes from the endpoint and then the time to live, the number of milliseconds that it took, so on and so forth, this is letting us know that we're actually getting a reply from this and it's up and it's running and it's not blocked by a firewall. It's responding, right? The ping output is an indicator that it is online and reachable. We've transmitted 5 packets, and we notice that on average it took 0.475 milliseconds for the reply to reach our system, the maximum length being 0.636. So from pen testing, we'll try to discover more about this, and we can learn as much as possible, for example, which ports are open and what's running. And we would do other types of attacks, or other types of scans, I should say. And we're going to be doing a good series of videos on Nmap inside of the network security module that we're in. So we're going to be talking about advanced Nmap scans and things like that as well. So we can shut down the target virtual machine and then try to ping this, and then we'll see that we're not going to get anything, right? It says destination host unreachable. So if we actually turn it off, if I turn this thing off, then these were the types of responses that I would get. From the attack box IP address, it was sent, but the destination host was not reachable. And this is what you'll see when the destination host, being this thing, is not up, or maybe even it's behind a firewall, right? So we already know that we shut down the target. For each ping, the system is using the attack box. In this case, is responding with that the host is unreachable, and we've transmitted 5 packets, but none of them was received, meaning that 100% of those packets were lost. The packets that we sent, none of them were actually received in return, so they were lost. We don't get a ping reply back. If we don't, there are a few explanations. The destination computer is not responsive, so it's still booting up or turned off, or the OS has crashed. It's unplugged from the network, so there's no internet connection, or there's a faulty network device. The firewall is configured to block these types of packets, and it could be a software that is running on the system or on a separate network appliance. In either case, it'll stop it, it'll block it. And on Microsoft Windows, it's blocked by default, and on Mac OS, it's also blocked by default because, again, we want it to be protected against denial of service attacks. And finally, the system is unplugged from the network, so it has no internet connection, therefore you can't establish that connection. So which option would you use to set the size of the data that's carried by the ICMP echo request, the size of the data would be something different. So if we look at the manual for ping, we can see that C would be for count, I would be for interval, capital I is for the interface, capital W is for timeout, P is the pattern, S is the packet size, T is time to live, capital T is timestamp, etc., etc. So S is what we're looking for here, which is the size. So we can just do a dash S here. And what is the size of the ICMP header in bytes? So I think we can probably get that over here. So it says 84 bytes of data, but that was on the failed connection. Over here, it also says 84 bytes of data. So it's either 56 or 84, but I want to say it's 84. So let's try 84. Oh no, it actually says what's the size of the header in bytes, and it's a single digit. So what would be the size of the header in bytes if we actually went ahead and did this? I feel like I actually need to run it in order for it to work. So let's go ahead and find that answer by doing an actual scan or a ping attempt with our target machine. I need to go ahead and take this because I know this is the thing that we're going to be trying to scan here. I'll leave this thing open just in case we need to refer back to it. And now we can open up the attack box here and go into full screen and then do our ping command. So this is a Linux machine. It is Ubuntu distribution. So we will go ahead and click on the terminal button, open it up, and we're going to do ping, and we're going to paste the IP address. Oh, come on. All right, so I guess I got to go and copy this now and paste it. Very good. Boom. And I forgot to limit the number of counts. So the header, it says 56 84 bytes of data. So I don't understand why it's giving me a single digit. So let's stop it from running. You see how it keeps running until I stop it, right? So I'm going to do Control C to stop it. So at the bottom, let's see if we get any information right here. 19 packets, 19 received, time, minimum average, etc., etc., etc. Doesn't give me a single digit number of bytes, which is what I find interesting. Now, I know that each, maybe this is the thing, that this is actually bits and they're saying that it's bytes. So if we divide it by 8, maybe we'll get our answer. Let's see what it is. Okay, the hint says to use the ping manual to see what it is. So maybe that's where we can find the information we need. So we will go ahead and pull up the manual by just doing man ping, and it'll pull up the manual. So let's see if we can find the number of bytes that is sent. All right, under packet size, we can see that the default of the bytes that's being sent is 56, which translates into 64 ICMP. When combined with the 8 bytes of ICMP header data. So the header would be 8. Now, does the Windows firewall block pings by default? We already read that it does. And deploy the virtual machine for this and issue this right here. How many ping replies did you get back? I'm going to say if I'm going to send 10, I'm just going to say that I'm going to get 10 back because it was up and running. So we already did the ping ourselves, and it gave a response to every single one that we sent. So actually, sorry about that. If we go look at it right here, we can see that 19 was received from the 19 that was sent. So we can just assume that if we send 10, we're also going to receive back 10. So that was ping. Now let's go and talk about Traceroute. As the name implies, the Traceroute command traces the route that is taken by the packets from your system to another. The purpose is to find the IP addresses of the routers, and these are referred to as hops when we use Traceroute. And it's looking at the addresses of the routers that a packet traverses as it goes from your system to the target. It reveals the number of routers between the two systems, and it's helpful that it indicates the number of hops or routers between you and the target. But the route taken might actually change as many routers use dynamic routing. So it most likely, every single time that I've done it, I get different results. It's rarely ever the same number of hops or the same number of routes that it takes. The maximum is 30, and you'll also see that when we actually run the command. And somewhere in the middle, you will also see the router of the internet service provider, because it'll go from us to whatever, and then it'll go to the internet service provider's router, and then whatever, and it'll end up at the destination of the IP address or whatever that we're trying to connect to. On Linux and Mac, the command is traceroute, and on Windows, it's traceRT, and it tries to discover the routers across the path from your system to the target system. There's no direct way to discover the path. We can run ICMP to trick the routers into revealing their IP addresses. We can accomplish this by using a small time to live on the IP header. And in this case, TTL stands for time, so the T in TTL stands for time. And then TTL itself indicates the maximum number of routers and hops that a packet can address or it can pass before being dropped. So it's not a maximum number of time units in this particular context. It's the number of routers that it will hop across. So when a router receives a packet, it decrements the TTL by 1 before passing it to the next router. So if we start at 30, it'll decrement by 1, it'll be 29, and then 28, etc. So the following figure will show that each time the IP packet passes through a router, the TTL value is decremented by 1. Initially, it leaves with a value of 64, and it reaches the target with a TTL of 60, meaning that there were 4 hops that it took, right? So if we go, oh, this is way too zoomed in, or zoomed out, excuse me. So if we start here, it's kind of hard to tell because it's dark colors right here. Let me see what the recording looks like. It almost, you can't even see it in the recording. But so there's an IP address that belongs to this computer right here. And then there's the information that's down here. Maybe this might be better. I'll just zoom in here manually for you. So this might be a little bit easier to notice the information. So this is the first one, the first set of images that we see right here. So these are all routers, okay? These are the icons typically universally for routers. So it's coming from this and it's trying to end here. And the fastest route that it can take is this 4 hops that you see, these 4 direct hops that it took. So the TTL 64 is what we see right here. So the time to live 64, right? And it goes through each one of these hops. So you can see this one will turn it into 63. The next one will turn it to 62, then 61. And ultimately it ends at 60 by the time that it gets to this end device that we're trying to connect to right here. So it decrements by 1. It starts at 64, decrements by 1. If the TTL reaches 0, it's going to be dropped, and an ICMP time to live exceeded would be sent to the original sender. In the following figure, the TTL is set to 1 before sending it to the router, and the first router on the path decrements by 1, and it reaches 0 immediately. The router will discard the packet and send in time exceeded in transit. So we can see this one right here. It's much quicker than the other one that we saw, right? So we have a bunch of routers, but initially what we see right here is TTL was sent to 1. And so literally after the first hop, it's just going to discard it. And then it will come back and it said time exceeded in transit because it takes more than 1 hop to get to this one. No matter what route you take, you can take the shortest route. It's still at least going to take 4 to be able to get to the end. And if we do it by 1, usually if you set a TTL of 1, it's always going to come back as time exceeded. So Traceroute will start by sending UDP datagrams with IP packets of TTL being 1, and this is on Linux. Thus, it causes the first router to encounter TTL 0 and send an ICMP time to live exceeded back. TTL of 1 will reveal the IP address of the first router. Then it will send another packet with TTL 2, and it will be dropped at the second router, and so on. So if we try it on a live system, we'll get some interesting results. So same command, right? From TryHackMe's attack box, we notice that different runs will lead to different routes being taken. So this is the first example. And so we ran right here. It starts right here, right? This is where we're at. It starts right here, and then it goes, and then you can see that it's going to go, and then we have the number next to each hop that's being taken, right? And then it takes 14 hops to get to the destination right here. So we can see that right there. And then we'll come to the next one. And so let's actually look at this element right here. So the line reading 1299 shows the time in milliseconds for each reply to reach our system. So it says consider line 12, which is this one right here, the 12th connection. Depending on the 12th router which listed IP address has dropped the packet 3 times and sent an ICMP time exceeded in transit message. So if we look at the end of it right here, so line 12, we can see there were 3 times, right? And then there was no connection to the next one. It just stopped. There's nothing else after it. This one right here, it actually says, so it sent it, this was number 11, 19.7 milliseconds, and then this was the destination, and that you can see that, and then this one again, destination, you can see that, this one you see, so you can see the IP addresses of each connection that it actually attempted. This one, it doesn't give us anything, right? That's it. It just stops. It drops it. Stop, drop, kaboom. So that is what we have over here, and it shows us the time in milliseconds for each reply to reach the system. These are the ones right here. So on the other hand, we can see that we received only a single reply on the 3rd line. The 2 stars in the output, you can see 1, and then you can see 2 right here, indicate that the system didn't receive 2 expected time exceeded in transit messages. And in the first line of the output, we can see that the packets leaving the box take different routes. We can see 2 routers that responded to the TTL being 1, and our system never received the 3rd. So this is in the very first line of the output right here, right there. And it says that there was just 1, it seems like, right? I think, because if we're counting this as the first one, this is leaving the Amazon AWS cloud, because that's technically where it started from. And so that would be considered the first hop. And it says that the packets leaving the attack box take different routes, and C2 routers that responded to it being 1, and the system never received the 3rd one. So that was the first example. Now this might be over your head if you don't have any experience with networking, or if you don't know what Traceroute is. I can understand that this could be a little bit overwhelming, which is why I always recommend you study a little bit of networking to understand what this is. There's CompTIA Network Plus playlist on this channel, and that is comprehensive, and it'll teach you a lot about networking. So if you're interested in that, it'll help you become a more proficient hacker, because you will understand what all of these things actually mean. So now this is the B scenario. So the last one, so in example A, it took a total of 14 hops. In example B, we can see that it's taken 26 hops, right? The package took a longer route, being 26 routers. If you're running it to a system within the network, the route will unlikely change. However, we can't expect the router to remain this fixed when the packets need to go via other routers outside of our network. So if it's inside of our network, we know that we have a handful of routers, so the packets should remain relatively the same. The path should remain relatively the same. But if it's going outside of the network to a different country, to a different state, whatever, it's leaving your local area network, then it's not going to be the same, right? It's not going to take a fixed route. So to summarize, we can notice the number of hops and routers between the system and the target depends on the time that you're running Traceroute. There's no guarantee that your packets will always follow the same route. Even if you're on the same network or you repeat the Traceroute command within a short period of time, most likely you're not going to get the same route, because there's dynamic protocols in place to make sure that it takes different routes to prevent predictable patterns from being tracked, and people doing things that they can find, or that people tracking your activity so that they can see which routers they need to go ahead and manipulate and which IP addresses, etc. So all of that stuff is now accounted for when you take a dynamic route, so that if somebody's watching this and doing Traceroute every single time, there will be different routers with different IP addresses that show up. Some routers return a public IP. You might examine a few of these based on the scope of the intended pen test, depending on what you're doing. And some of them don't return a reply. So in the first example, what is the IP address of the last router hop before reaching TryHackMe.com? So if we are trying to reach TryHackMe.com, in this particular case being this IP address, so this is what we're trying to reach. So this would be the last one right here. So what's the address of the, in the first example would be right here. And the IP address that we're trying to reach is this, which would be the last place that it will land. So what's the IP address that we were at before we got to the last one? That would be the one. So we go to here and we paste that in here, and it says it's wrong because the format is not right here. So the IP of the last router before reaching TryHackMe.com, I want to say that it's that, but it seems to be the wrong answer. So let me see here. I mean, I guess we can take this and try this. I don't know why, because I feel like that was the destination, but maybe it's not. So let's see if we try this here. Okay, all right. So in Traceroute B, what's the IP address of the last router hop before reaching TryHackMe? So there's going to be this one example right here. So this would be the answer if that's what they're referring to as the last router. So we can go ahead and drop that here, and that should be an answer. In Traceroute B, how many routers are between the two systems? So I guess, well, I'll try it. I'll do 26. Going for the obvious answer here. And okay, that is it. So start the attached virtual machine from task 3 if it's not already started. On the attack box, run this. How many routers hops are between there and the target VM? So we'll run it. There's no actual answer for this because remember, it's going to be a different number every single time that we run it. But we'll run it just to see what we actually get, right? So we'll copy this, go over here, and we'll run the command. And then let's see what we actually get as a response the first time. So the first time it took one hop. That's kind of crazy. So let's go and we'll run it again, and it took another hop, and still one. So this kind of it's interesting. It's taking one hop every single time that I run this. The time to live is different each time. Yeah, it's taking one. That's so interesting. Okay, so complete. Maybe it's because they're inside of the same exact network. We're using the attack box on a virtual machine on the TryHackMe network. So that might be the one. Now it says if Traceroute is not installed, you can install it with running Traceroute install apt install, but it's already installed because it's actually working. Just it's very interesting that it's only taking one hop, and it can only be presumed that it's taking that one hop because they're already inside of the same cloud environment, the same network. So, all right, let's move on to Telnet. The Teletype network, not to be confused with Teletubbies. So the Teletype network is a protocol that was developed in 1969 to communicate with the remote system via the command line. The command telnet uses the Telnet protocol for remote administration. The default port is 23, and from a perspective of security, this sends all the data, including usernames and passwords, in clear text. So we don't want to use this. This is something that is definitely outdated. So whenever you're connecting to something, you definitely don't want to use Telnet. And when you're scanning something and you see that port 23 is open, you can rest assured that whatever's going on that port is all in clear text. It makes it easy for anyone who has access to the communication channel to steal the login credentials. The secure alternative is Secure Shell, so on port 22, right? So when you try to connect via Secure Shell, everything is now encrypted, not decrypted. So nothing is in plain text anymore. You can't, even if you're watching the traffic on that port, you won't be able to see anything without getting some kind of a decryption key or going through that whole process to decrypt it, because everything is now encrypted. So knowing that this relies on the TCP protocol, you can use Telnet to connect to any service and grab its banner. So you can do Telnet and then the IP address and then give it a port. And you can connect to any of the services running on TCP and even exchange a few messages unless it's using encryption. So let's say we want to learn more about a web server that's on port 80. So we can connect to it on port 80 via HTTP. You don't need to dive into this protocol. You just need to issue the GET, and this specific / represents the home or the root location, and then you give it the version of HTTP. In this case, it's getting the page HTML. So it's not just looking at the root, it's looking at root page HTML, right? So it's getting this data, not just what's on the root. And then which will request the page HTML. We also specified to the remote web server that we want to use HTTP version 1.1. To get a valid response, instead of an error, you need to input some value for it. So for example, the host itself, and then hit enter twice. This piece is very important. Executing this will give us the requested page. So telnet, IP, and then the port. It says trying to connect, connected, escape character is that. So then we say get / HTTP 1.1. And then it'll say host. Once we press enter on this, I should say, then we give it a host, which is going to be telnet. And then the first enter that they entered is this empty space that you see right here. The second enter is where they got the 200 response, the success response, and then this data was retrieved from the server. So of particular interest for us is discovering the type and version of the installed server, which is what we can see right here, the server Nginx 1.6.2, because from there now we can do recon against this version of Nginx to see if we can find any vulnerabilities. So if we connect to a mail server, we would need to use proper commands based on mail. So for example, SMTP or POP3. Since we're using HTTP, or we're trying to connect to an HTTP, we would be using HTTP commands. For example, a GET request, which is all about HTTP. So start the attached VM. On the attack box, open the terminal, use the Telnet client to connect to the VM on port 80. What is the name of the running server? So let's go here and let's run it, right? I'm just gonna clear the screen just to make it a little bit easier for us to see what's up here. And we're gonna do what? Telnet. I totally forgot what the IP address is, so let's do this and we'll do that. Not that, we'll do this. So there we go, there's the IP address. So we'll do Telnet 10.10.31.29, and then we're going to do port 80 like that. Press enter, trying to connect, and the connection is established. So now we're going to do the other piece of it, which was what? We need to go and do the get request. So we're going to get the request, and does it say what to get? What is the name of the server? No. So it doesn't say what to get. So we can just do a basic get request and then give it a host of Telnet. So we'll do the same thing. Get in all caps /HTTP/1.1, enter. And then host is going to be Telnet, enter, and then enter again. And there we go. So now we have Apache 2.4.61 is going to be the name of it. And so there we go. So we go down here, and actually we just need the name Apache, it seems, because we don't need the version. So what's the version of the running server? There we go. So what was it? It's 2.4.61, 2.4.61, and there it is, just like that. And now we can use Netcat to do something similar. This specific task has its own virtual machine, so I'm going to go ahead and crash this one. And then we're gonna wait, and then there we go, we're gonna start that one. And while that is loading, we're gonna read through this specific documentation. So NC refers to Netcat, and it can do a lot of things, because you can actually establish a connection, a remote connection, using a reverse shell or a shell via Netcat and some kind of other payload to establish that connection from you and the target server or the target machine. So it supports both TCP and UDP. It can function as a client that connects to a listening port. Alternatively, it can act as a server that listens on a port, and it's a convenient tool to use as a simple client server or TCP UDP. So you can connect to a server as you did with Telnet normally, and to connect to it, you just do Netcat. You give it the IP address that you want to connect to and the port number that you want to connect to. And it's very similar to what we were just doing with the Telnet command that we did. And you can do the get connection again, very similar to what it is. Now it says doing shift enter. What just happened? Doing shift enter after the get line might be necessary so that it doesn't just send it. So after this, you would do shift enter, and then you would do host, and then you would do your enter, and it should receive the same information. So we're establishing connection as a client right now by trying to request to this IP as a server, okay? It connected to that on port 80. Next, we issued the get command specifying the target, HTTP, whatever. Then we needed to give it the name of the host, very similar to what we did with Telnet. And then based on that, we saw the output on port 80, and we have Nginx, right? So now we can do this to listen, and now we need to give it, in order to do that, we need to give it these queries, these options right here, and then we give it the port number that we want to listen to. Now, if we are, or listen on, I should say, what we're doing right here is combining all of these flags as if we were doing them individually. So this will actually look, or it'll do the same thing as if you just did individual flags like that, right? So we can also look at the meanings of this. So if we do -L, we're in listen mode. -P, we're looking for a specific port, or we're trying to listen on a specific port. -N is numeric only, meaning that it doesn't do resolution of the host names via DNS and try to get you words or names or IDs or anything like that, user IDs and things like that, host IDs. It'll just give you the numeric. And then V is for verbose. You can also do VV for very verbose, which will give you detailed output essentially. And then -K will keep listening after the client disconnects. And I rarely use that, but that is a really interesting option, a useful option. So the option P should appear just before the port number and will avoid DNS lookups and warnings, and port numbers less than 1024 require root privileges, so use something higher than 1024 to make it work for you. On the client side, so this is a server, right? So when you do this right here, you're now turning your machine into a server that is listening, and then the client side would try to connect to it. So on the client side, they would do the connection right here, and then they would use the port number that you just issued right here, this thing, and that would be to use to establish the connection to the server that you just set up. After you successfully establish the connection, whatever you type on the client side will actually be echoed on the server side. So on the server side, for example, we can listen on port 1234 with the command, netcat vnlp 1234, which is the same thing as lvnp, doesn't really matter. The last piece is that P needs to be there so that we can assign the port. In our case, the listening server has that IP address that we see right here, so we can connect to it from the client by doing this, and this setup would echo whatever that we type on one side to the other side of the TCP tunnel. And we can find that below, meaning the recording of that process below. The listening server is on the left side of the screen. So I guess we're going to try to do that. So on the VM, open the attack box. We already did that. And on the attack box, we're going to use Netcat to connect to VM port 21. What is the version of the port? So the virtual machine that has been assigned, which is this thing right here, basically, that's the one that I clicked on, the start machine. This is now the new one that we got. So that is now acting as our server. So our attack box is going to be the client that's trying to connect to it. So we would then do netcat, and then we would try to connect to the IP address, which is this thing right here. So let's see if we can just copy this and hopefully it'll work. So I'll do paste, and then I'm going to try to connect on port 21 like that. Press enter, and it says that it's ready. So let's try to connect, same. So we'll do get / and then we'll do HTTP / 1.1, shift enter, and command not understood. So okay, let's see here. It says try to connect to it. What is the version of this running? So let me see, maybe did I do something wrong here? I think the big issue or the mistake that I made is that I was trying to connect to port 21, which is FTP, using an HTTP connection, because this example that they gave us over here was for port 80, which is HTTP, and then GET is a request that's done through HTTP. So the command itself was not recognized because we are not doing anything for HTTP. We're actually connecting to an FTP that you see right here. So we're talking to an FTP server. So I guess I would, if I do ls, will that work? No, this doesn't work either. So let me see what it is that I need to do here. I think the answer is actually a lot simpler. So the connection was established, and it says, right, the West Compute Internal FTP server version 6.4 OpenBSD Linux FTP 0.17. So it seems like all of the information that we need was that initial response that we just got. So what is it? I think it's 0.17 maybe. Is that it? Yeah, that's it. There you go. So I didn't even need to do anything else. You just need to do that first command to actually establish the connection. And once you've established the connection, the response that you get will tell you what kind of server that's running and the version, etc., etc., etc. So just like that, we have now wrapped with Netcat. So let's put it all together. So if you went through the CompTIA Linux Plus playlist, the very last video has a lot to do, or everything to do, with scripting and creating some shell scripts inside of Linux. And you can use just some very basic commands to create a shell script that will be what they're calling over here a primitive network and system scanner using Traceroute and ping and Telnet. And it'll basically, you can design that shell script to output the results for you into a file, and then you can use that report later on to get the results of all of these things that were ran to see what happened, right? So you would do just the traceroute command, next line, then the ping command, next line, and then you would just output all of that stuff to an external file, an output file, and then you'll be able to look at all of the results just to see what information you can gather about your target. So what we're going to be doing is using Nmap in future videos to make a more complex scanning attempt against our targets, and you can get a lot of information with Nmap. So all of this stuff is just to lead up to it, just so you can see what's available for you without Nmap and the stuff that you can find without Nmap. But then Nmap will end up being kind of your godsend. It'll end up being your favorite tool when it comes down to active scanning and reconnaissance and things like that. And you can even do vulnerability scanning with Nmap. So not just recon, but you can even try to find vulnerabilities against the target and the various services that are running on the target. So really, really powerful tool. These are just some of the commands. We did the ping, using the count of 10 on Linux and Mac OS. If you do N10, it'll be Windows version of it. Traceroute on Linux and Mac OS, or TraceRT on Windows. Telnet works across the board on whichever device it actually has it installed. Netcat as a client, so you're connecting to the server, and then Netcat as a server, meaning to turn your device into a server that's listening. So these are fundamental tools, but they're literally available on pretty much every distribution of Linux that you actually install, especially if you do Kali Linux and Parrot, because I believe Parrot is also designed for pen testing. So web browser is installed on pretty much every single computer. If it's not, then that computer is so freaking old. And if you want to gain more information about what you can do with the web browser, you can go through the room walking an application, which is what we did at the very beginning of Junior PenTester. Was like one of the very first videos that we did, maybe like the third or fourth video that we did, that we were talking about walking an application and the information that you can find through your web browser. So Linux and Microsoft Windows, you can do Control-Shift-I to get into developer tools. On Mac OS, you can do Option-Command-I, or you can right-click on the screen and then go to Inspect, and it'll immediately just open up your developer tools, and then you can find information from the web browser that way. So a lot of different options that are available for you, and hopefully this was serving useful. This actually served as a useful maybe reminder if you've gone through this before, or if you've never been exposed to any of this stuff, then now you have a really good understanding of what it means to do active reconnaissance. And as we go along with the network security module that we're on right now for Junior PenTester, then you'll be able to see what we can do using Nmap and the power that is available inside of Nmap. So really, really excited for you. I think there's a lot of cool stuff available in your future, and you're going to get a lot of value from everything that we're going to be doing inside of the network security module. And with that, I'm going to click complete, and we're going to do our wrap up. If you found this video useful, and if you would like to get more videos like this one, I encourage you to like, subscribe, and turn on that notification bell so that you get notified the next time that video comes out on this channel. And the notification bell is literally a bell that's underneath the video. And there's a lot of stuff that's going to be coming out. We're going to be talking about a lot of things, including the finishing of the CompTIA Pentest Plus playlist. So this is new episodes from this one, drops every single Friday. And of course, we're inside of the Junior PenTester playlist as you're watching this. So we're going to wrap up everything inside of Junior PenTester, which is a part of TryHackMe. The CompTIA Pentest Plus training series is something that I developed based on the guidelines of CompTIA for the most recent version of Pentest Plus, which is the PT0003 examination. So even if you don't go through that certification exam, it's just useful to know this information, because the skill is more important than the cert. I say this all the time. If you can establish a portfolio or a GitHub repo or something like that and demonstrate your skill sets, you are just as valuable as anybody that went through and got the certification. Maybe even more valuable, because a lot of people are really good at studying, but they don't apply it, so they don't have a portfolio, they don't have a GitHub repo, and for that reason, that might be the, the reason why you would get the job. If you're looking for a job in this world, you would get the job over somebody else who has the cert, because you actually have the skill set, you have a repository, you have a portfolio, etc. Network Plus is already finished. This is exclusive to Hackaholics Anonymous. Security Plus is already finished. Linux Plus is already finished. And of course, there's CySec 101. If you have not gone through that, highly recommend that you go through CySec 101. And then we have, this is the members only section. We have SOC level 1, SOC level 2, security engineering. These are all completed playlists as well. And then if you're looking for anything specific, for example, Python, let's say, you can go and search for Python, and then you'll find the Python algorithms for cybersecurity video, which is also one of the more popular videos. I teach you the very basics of Python, and then we build on it. And then by the end of that training series, we end up building algorithms for cybersecurity. So a lot of really, really cool stuff available on this channel. And if you haven't done it already, I highly encourage you to browse through the contents to find things that you want, or maybe even search to see if there's anything in particular that you're using or looking for. And until then, in anticipation of the next video that comes out, make sure that you like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out. And of course, drop a comment if you have any questions or anything like that. If you're serious about your CySec training and want access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the supporter, agent, guardian, and master. Each tier gets their own Discord server and early access to content. The agent, guardian, and master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you'll be able to join Hackaholics Anonymous. I hope I see you in the Discord chats. If not, I hope I see you in the comment section. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker/protector. If no one else loves you, Hank loves you. Love, peace, and chicken grease, and I will see you in the next video later.